Hello, welcome to Astronomy, Chapter 17. Now at this point we are in the home stretch. We are almost done with this course, and perhaps the best news that I can give you in this video is that Chapter 17, I believe, is actually the shortest chapter in the whole book. So that's great news. It's only about 10 pages long, and so this video is going to be very brief to introduce the concept of quasars and active galaxies. Really, there's not a lot in here, so when you go through this, it should be a very brief chapter, which is good because we're almost certainly at the end of the chapter now, or at the end of the term, and we need to be wrapping this thing up pretty quickly. Okay, so first off, I want to introduce the idea of what is a quasar. And a quasar is actually one of those things that if you look on page 524, they give you an explanation of what a quasar is. And it is essentially something that looks like a star, but has a huge redshift. Now, remember, redshift, we talked about last chapter, redshift means it's moving away from us very fast. And when we're looking at with quasars, which the name comes here from quasi-stellar radio sources, you can see that on the bottom of 524. What we're looking at is we realize when we're looking at these objects and all active galaxies, we're looking at things that have an absolutely mind-boggling amount of energy coming from them. These are very high energy sources. And really, these last couple chapters represent, and really this chapter in and of itself could actually represent an entire subdivision of astronomy we call high energy astrophysics, where we talk about what happens inside of these huge energy sources. For example, they talk about at the beginning of the chapter when you're doing your reading that some of these emit more energy per second than the sun does in 200 years. That is just a staggering amount of energy to be released out of any source. And so the question must be begged, how in the world is something capable of sending out such tremendous energy? Perhaps the most exciting answer to that is it's not fully understood. It is not. It is one of many topics that we do not fully understand. But what we do understand about them is that this huge amount of energy is coming from a very small volume. That means we're talking about a galaxy that is on the order of, or something that looks like, a star. It says galaxies are big and bright. A typical galaxy contains hundreds of billions of stars. But then it says quasars can easily be seen more than 13 billion light years away. They must be far and more luminous than other galaxies. So what we're talking about is we're talking about galaxies that are tremendously far away, but are emitting tremendous amounts of energy. And so there is some sort of active flare-up, if you will, of this energy coming out of them for us to be able to see them. And when you're going through your reading, you'll get into some of the explanation of how these real powerhouse systems are able to do so. Now, there are other types of active galaxies. There are things, we can have active galaxies that can be spiral or elliptical, and they're usually referred to as Seyfert galaxies. I'm talking about having this powerful emission of energy coming from their core, which is a very exciting part of understanding the end of these galaxies. Now, the thing that I've hinted about this in several chapters earlier is what could possibly be causing this. And one of the things that we look at is the biggest of the baddest is the supermassive black hole. We now have significant evidence and growing belief that a supermassive black hole is at the center of most of the galaxies we see. And that appears to be the motor, if you will, that keeps these things going. And so there's a lot of exciting stuff about what must be going on in order to create this black hole at the center of the galaxy, and how this is essentially the core of the galaxy that is holding the thing together. And they show you some great diagrams inside of it. Here's M87, which is an elliptical galaxy, showing you the diagram of why we think that there are galaxies at the center of those holes. Well, some other evidence for this is that we see these jets. We see energy being emitted out of them And here on the top of 531, we see a diagram of this material being shot out of this. Around here is an accretion disk, and this is supposed to be a cross-section, if you will, like we're looking into it. And the black hole, and right around the event horizon, we see this big accretion disk, and then we see these materials being shot out of this, and giving us this massive pressure shooting material away before it is pulled in to the event horizon. So sort of this kind of giving us almost like you can think of it kind of like a flag sticking in a hole in a golf course to give you an idea. There's something right there. There's got to be something going on right there. It gives us a clue as to what must be going on there. But nonetheless, the gravity is ultimately the thing that ends up driving all of this. And as you go through reading the 10 or 12 pages associated with this, the end focuses there a little bit on how gravity ends up being the major part that is holding this thing together. So that'll give you the basics of what's going on with Chapter 17. Like I said, quick chapter. It's a short read. Make sure you're keeping up with that. Check out the PowerPoint, and you'll be ready to do the homework assignment for this chapter. Good luck.